Hello, we are Group 20, composed of Kyra Boudreaux, Victoria Johnson, and Kyle Territo, and today we will be presenting the Big Bang of body types. What are the physical characteristics that define the body type of an elite athlete? Is it strength, coordination, height and weight? A brief examination of the world of elite sports today shows a wide range of body types and physical traits prevalent across the sporting world. Why is this? Sports are not physically monolithic. They require different skills and athletic abilities from their participants. As such, the human body has adapted in elite athletes to better perform in their respective fields. In his book, The Sports Gene, David Epstein discusses the emergence of different physical traits in the sporting world in the 20th century. In his book, Epstein quotes the theory sports scientists Kevin Norton and Tim Olds put forth. The rapid evolution of athletic bodies from average to specialized is a quote-unquote big bang of body types. Epstein displays this theory by comparing how the human physique has been viewed over the past few centuries. 19th century researchers concluded the human physique fell in a bell curve, with the peak body condition being at the top of the curve in the average range. Da Vinci's Vitruvian Man was the model of this theory and was heralded as the pinnacle of male fitness. When athletes began specializing in sports in the early 20th century, the model of average body type was replaced by specific body types for each sport. As such, elite athletes in the modern era are at a genetic advantage as their body types are better suited for specialized performance. The world of athletics and of the athletes who compete within have greatly changed over the past 200 years. As such, the genetic makeup of the athletes who reach the elite level of these sports have drastically changed. We will examine a few different sports to categorize how athletic body types have changed over the years.
Basketball is the next sport that we will talk about. Basketball is one of the most popular sports to watch due to its nonstop action and entertainment. Over the years, the average basketball player physique has changed dramatically. Some noticeable characteristics of current basketball players in the league are height, wingspan, short torsos compared to long legs, and large hands and feet. In this table, we have this 1947 average NBA height and the 2021 average NBA height. In 1947, the average height was 6 foot 2.13 inches, and in 2021, the average height was 6 foot 6.33 inches. This is a comparison of basketball teams from 1947 to 2021. The basketball team on the left is the Lakers team in the first year of the National Basketball Association, and on the right is some of the most popular basketball players from the 2021 season. One of the most popular basketball players in recent times is LeBron James. LeBron James has been in the NBA since 2003 and has been a favorite of many people. Some things that make him special are his dimensions. His height is 6 foot 9, his weight is 250 pounds, his wingspan is 7 foot 1 inches, and his shoe size is 15. An interesting correlation is from height and wingspan. In this visual, we can see that many basketball players are super tall and have a wide wingspan. On the other hand, several professional boxers are depicted on the graph to show that they too have large wingspans to help in the boxing ring. They are also shorter compared to basketball players in order to have a lower center of gravity to aid in balancing while fighting. Although there are many uncertainties in ongoing studies about genes and their contributions to determining someone's height, one gene called HMGA2 gene has been associated with different height distributions.
Women's competitive gymnastics is an all-around sport that requires an abundance of physical characteristics and skill in order to succeed. Physical abilities that play an important role in a competitive gymnast's success include speed, strength, endurance, agility, flexibility, balance, and power. The common trait among gymnasts is that they tend to be short in height. While there is a biological reason for stunted growth due to the insane amount of physical training they endure, There's also an athletic reason. Being short gives you an advantage in gymnastics due to the physics involved in the motions. Athletes who have to rotate in the air, such as divers, figure skaters, and gymnasts, have seen a change in height over the years. In the last 30 years, the average height of elite female gymnasts have shrunk from 5'3" to 4'9". Here we can see a physical representation of Nadia Comaneci from 1976, who was 5'4" and approximately 123 pounds. You can see that she is slimmer, taller, and not very built when it comes to muscle. To the right, we can see Simone Biles, who is current day one of the best of all time. She has a height of about 4'8" and 104 pounds. We can see she is more short, compact, and very toned, muscular. Based on how gymnast bodies continue to evolve, we can see the skill levels also change over time. One example of how gymnasts changing have affected the sport's skill difficulty would be on the floor apparatus. This is Nadia Comaneci in the 1976 Olympics performing a tumbling pass. Today, tumbling pass capabilities have reached new heights since gymnasts have changed and are able to put their bodies to new tests of difficulties and fly through the air with less resistance. When you think about gymnasts and gymnastics, one of the first thoughts that comes to your mind is probably how flexible they are and how they get that way. Flexibility is important in gymnastics because without the right range of motion, gymnasts will be unable to learn how to do certain skills. They will also receive deductions when they cannot reach a certain position. As an example, when gymnasts do not perform split leaps at the angle required by their gymnastics level, they receive a deduction. Different sports require flexibility at different places in the body. For gymnasts, hip and shoulder flexibility is important in order to do many skills. Hip flexibility is important for splits, jumps, and leaps. Shoulder flexibility is important in order to do bridges, back handsprings, and numerous other skills. The COL5A1 gene is called the flexibility gene. This helps produce the type 5 collagen. Collagen helps in strengthening your bones, muscles, skin, and tendons. It keeps your joints mobile and flexible. Lowered levels of collagen can result in stiffness and reduced flexibility. It is believed that the most flexible gymnasts are those that contain this flexibility gene.
Both the HMGA2 height gene and the COL5A1 flexibility gene are currently being studied for correlation in elite athletes. While HMGA2 is one of the primary genes encoding height, it does not necessarily dictate the large stature noticed in basketball players. Current research into HMGA2 links it to tumorigenesis in pituitary tissues. Scientists hope in the future to produce a cell line that represses HMGA2, leading to a decrease in carcinomas but also possibly stunting height growth. With the COL5A1 gene, scientists have found a link to ligament injury. Some variants of the gene are more likely to lead to ACL or Achilles tendon injuries due to increased flexibility in those areas. However, scientists still have to study the possible downside of the COL5A1 gene as opposed to its benefits.